Welcome back to the Grand Solar Minimum channel. Today is April 2nd, Monday, 2018. Hope everyone had a great holiday weekend. Let's get right into it. Take a look at our space weather conditions first. Our solar wind speed sitting at 416.6 kilometers per second with a density of 4.4. Taking a look at our sunspot, guess what? It decayed today. AR 2703 started off strong after seeing a little bit of a C-class flare on April 1st. It has since decayed. We are back down to sunspot 0, starting a new stretch of spotless days. Now the total is 53 days already for 2018, more than halfway than what we had last year for the entire year. KP indices are sitting at a 1 with a 24-hour max at 2, so no chance of any kind of geomagnetic activity at this time. And I want to get your attention here to the coronal hole that we are looking at now at SPACEWEATHER.com. Let's get a better look at it here. First, I want to take a look at the sunspot that kind of decayed. Let's watch it as we. I want to show the. There was a slight flare up right before it decays. Let me go ahead and zoom in for you guys. Get a better look at it, and I think right there is probably the C flare, and right after that C flare you see it just kind of sparking out and finally decaying away to nothing, as it is no longer named sunspot AR 2703. But back to the topic at hand, and that is this coronal hole that we have coming up. The gash that we saw in mid-March is returning now and will be Earth facing within the next couple of days. Now, this was the coronal hole that started the long duration of solar wind speed. We saw an increase somewhere between 450 and I don't think we got any higher than the 650s, so nothing huge. And it was a peak wind of 650 kilometers per second, but mainly we stayed in the 500s, 550 and up. But here we have once again this coronal hole that we saw in mid-March. It is approaching us now, so we will keep our eyes open for any update and activity from this. Also, I wanted to check the KP indices and the proton flux as well, just to show you after that little C-class flare. There you go, your proton flux. It briefly touched in the C-class area, and that was between the 1st and 2nd of April, so more chances that was going to happen somewhere probably in the evening. And after that, things just quieted off. It's like someone turned the switch off. Taking a look at our TSI readings. Now, we've had problems with the other data that we were following, which was for some reason 0.5 higher on the TSI measurement. So when we last checked the TSI back on March 12th, it was a 1361.1.70, I believe. And if we look at it now, bear with me folks, here is the 12th right there. Okay, so I said it was 1361.1, somewhere in that area. This is the reading that it would have been at if it was 0.5 lower. So 1360.7 was the last time that we were able to give you an update. And as of right now, today, we are sitting at 1360.64. So we've only dropped a value of total of 0.06 since overall since March 12th. But if you look back at the 16th, we've seen a bigger decrease in TSI, as values were right in the 1360.57 range, and then gradually worked itself back up. But really here in the last several days of TSI, it's been back and forth, up and down by 0.01 to 0.02. So nothing too spectacular in the TSI readings. Let's go over to GrandSolarMinimum.com. I highlight a few articles every now and again. The April snow, I'll go back to that here in a little bit. Wanted to talk about ocean temps. We briefly talked about it earlier. I think it was on Thursday before we went out, or it might have been Saturday. Ever since ocean temps peaked in January 2016, we've seen a steady decline. In fact, we are almost as low as we were in the last minimum in 2008, and we only have just begun the grand minimum. Now, thanks to the Starman channel on YouTube, his useful teachings has alerted me to these temps and has explained how all this works. He told me that he's observed rising and falling temps, but what he hasn't seen before is the drastic drop that we just witnessed in the North Atlantic. It's something to keep our eyes on. And here is an article that I wanted to direct everyone to, if the link works for us. Gotta love lies. Okay, here we go. Science Matters, and the entire article is here at this website here. The link is in the website and should be in the description. But this gives you the entire overview of ocean temperatures, and I was looking at this earlier, and what I found kind of amazing to me is the tropics, where the tropics are here, the light blue, the teal blue color, and it looks like to me like the most steepest on the most free fall decline right now that we've seen is the tropics. Just by basing it off looking at this graph from the rest of these values here, it looks like the tropics have dropped, in my opinion, the steepest. But like I said, we are keeping our eye on the North Atlantic temperature anomaly as well. But I found this article very, very useful, and I wanted to bring it up in tonight's show. That way everybody, if you get a chance, take a look at this. This will help you understand not only are we cooling down in the atmosphere, but our ocean temps are now starting to show that as well. All right, and Fiji, we had a cyclone there today. Josie, over 70 roads are closed and 35 evacuation centers have been activated for nearly 2,000 people. Unplanned power outages were also one of the challenges that were faced here. This storm brought heavy downpours and very little wind. In the comparison to Winston in 2016, Winston killed 40 as Josie only took 4 lives. With Winston, there was more wind than there was rain. Winston was rated a Category 5. Josie was only a Cat 1, but did damage with major flooding. And I also provided the link here as well. It takes you to watchers.news. A little side note here for this area. I don't know if it was this particular area, but Fiji and part of the southern part of their islands did experience a small quake out in the middle of the ocean at a 6.1. So very, very active region right now as far as weather and earthquakes go. Of course, we know Papua New Guinea and that area as well is very active. So far today, thankfully, it's been quiet. Nothing over, or no 6.0s from that region today. And the numbers from royspencer.com are out. And this is one of the things that I really watch. I've followed this since last year. And along with the SST values that I've been showing everybody in the ocean, this is the lower atmosphere global anomaly that Roy Spencer keeps track of. Now, a lot of you will go back to 1979 and say, well, that line looks like it's going up. And you're right. Up until 2016, we were warming. And after 2016, the warming has stopped. And the graph clearly shows that. And right now, we are seeing a decline in this anomaly. Now, for the month of February, we were at plus 0.20 Celsius. And now, March, we are at plus 0.24 Celsius. So it went up a 0.04. I don't call that much of a rise or decrease either way. January's numbers were a 0.23 Celsius. So we haven't seen more than a 0.01 rise in temperature in the lower atmosphere over the past 90 days. So right now, we're just kind of maintaining where we are. But if you look at the graph, you can clearly see we are starting to be on the decline. And since 2016, we've had one sudden rush of 0.63, and that was back in October of 2017. Most of the summer, June was in the lower 20s. July was at plus 0.27, and then it kind of climbed up in August in the 40s. And out of nowhere, October was a surprising plus 0.63 Celsius degrees. But overall, it stayed between the 20s and 40s in the values. And right now, we are holding steady at plus 0.24 degrees Celsius. I have the link in the grandsolarminimum.com next to this story here where I do a little write-up on it. Please go check this out. Again, this is just something else that we like to gauge how to monitor the climate, and I don't think there's anything better than to look at, especially guys like this guy here, Roy. Mr. Spencer puts a lot of work into this, and putting this graph together shows you the time that it takes to be able to witness these events right now. And this is a very slow process, and I look at this as my monthly Christmas present. I know it sounds weird, but this is the best way, in my opinion, right now, along with watching ocean temperatures, how to monitor temperature change and the changing climate itself. All right, we're moving on here. Miserable Easter weather in the UK. Hopefully everybody had a great holiday weekend, even with the bad weather that was experienced in the UK. The MET office warned citizens across the region that heavy downpours could leave cars stranded and planes grounded, as rounds of snow are also expected in the region. As of 8 a.m. today, 157 flood alerts and 16 flood warnings have been put in place across Britain. They're expecting heavy rain, 5 yellow weather warnings issued in the Met office as well. Swaths of Britain, and snow was expected across the country as well. So they were expected 77 millimeters of moisture to hit Wales, England, Northern Ireland. Flooding remains a threat for southwest England, Wales, and Northern Ireland. Much of England will be covered in snow. Go ahead and take you over to mirror.co.uk. Thank you, Mari. She dug this one up for me this morning, and I thought this was interesting to share as well for our viewers. This is probably one of the most significant weather systems or storms that's in place right now. I haven't seen this kind of damage from a storm here lately, so lots to look at. Snow, rain, flood, just a little bit of everything in that region. So if you get time, go ahead and go to our website, click on the link for more details and for more stats on this particular storm. And then here we have a little article, another one. I believe, Mari, you brought this to my attention as well. The oldest snapshot, 173-year-olds today. 173 years old today. Let's try that. This marks the 173rd birthday of this snapshot taken by of the sun. The photo was taken by, and I'm not even going to try to pronounce this name here, but these two guys here did this back in April 2nd of 1845. I had included the article here. Here's an insert. It kind of talks about the first few images that we had of our corona, and, you know, about solar cycles were starting to be a little bit more clear as well. This is just an interesting article on the history of how we observe the sun and how we've studied it throughout time, watching sunspots and corona and filaments and everything like that. And I know just from Mari, we have an H-alpha telescope, and looking through that really changes a lot of things when you see it on the internet, but then when you look at it with your own eyes through the H-alpha, and you could actually see the filaments, you could see the sun actually doing its thing. You know, that's for me anyway. I'm a geek, I guess, but it's a thrilling experience to be able to witness that with your own eyes. But I urge everyone to go ahead and check this article out. It's just a little bit of history on how our sun was observed and monitored back in those days. And let's go over here back to watchers. We got a couple of earthquakes to talk about. I'll briefly touch on these. A strong earthquake measuring 6.8 on the Richter scale hit Bolivia at 1340 UTC April 2nd, 2018. Now the depth of this was very deep, 346 miles. Earthquake can have a low humanitarian impact based on the magnitude and effect of the population and their vulnerability. There's 120,000 people living with 100 kilometers within this area. Only about 9,000 people were estimated to feel the weak shaking of this earthquake. And the one thing I really like about this article, well put together, very explanative about this was a minor situation. Here is a chart with some Roman noodles. You see the 2, a number 2 here, more 2s and some 1s. And down here in the legend, it shows you, you know, 9,000 people felt weak. 162,000 didn't feel this. And of course, anything after that, light, moderate, strong, very strong, severe, violent, extreme, of course, there wasn't any reports of any of that. So a lot of times you see that 6.8, and it just depends on where these earthquakes are actually located before we could assume if it was a damaging one. It may look impressive when you first get the report, but I appreciate articles like this that go into depth, that show us the magnitude, no pun intended, of these earthquakes. So, and then also briefly bring up the 6.1 earthquake that hit the south of the Fiji Islands today. A strong earthquake registered by the USGS as a M61 hit south of the Fiji Islands today at 5:57 UTC time. Now this one was only about 83 kilometers deep, which is 51.9 miles. This also says 86,000 people were estimated to feel the weak shaking of this earthquake. And again, another great example of, you know, letting us know the severity of this. This was nothing major. Again, this was just in an area where it just didn't affect many people in the population. So again, bravo to Watchers.news for bringing us the truth, reporting on these things. I find it crazy that we don't ever hear about earthquakes in the mainstream media, nightly news, or even the Weather Channel. Just surprises me. There's so much going on right now in that particular category, and we don't hear enough about it. Mets Phillies are snowed out tonight. Philadelphia. The game is going to be played there. They have rescheduled it for a doubleheader on July 9th. But more interesting enough, the Yankees were also snowed out today. Now, this one's a little bit more of a big deal to talk about. And the reason for that is that this was the first time that the Yankees have actually had their game canceled due to snow. First time since 1982. They broke a record. We have now over 15 inches of snow for the entire season for New York. And also, they got 5.5 inches of snow, which ranks 7th on the all-time record list for this date. So, or actually, for April snow, this snowfall ranked number 7. Again, 1982 was the last time that we had a game snowed out in New York, and I do believe that the Yankees will possibly be delayed as well tomorrow, as there's rain in the forecast. So they will probably not get to play. They were supposed to be off tomorrow, but because of the cancellation today, they're scheduled to play tomorrow. It looks like they might be pulling a doubleheader on Wednesday, and could be the possibility here. But I just wanted to report, we are early in the baseball season, but it's not usual to see 2 snowouts in one day, especially. All right. So we just got done talking about a few things with ocean temps, and today I'm going to start something new. When we go to Tropical Tidbits, thanks to the Starman, this is something I want to monitor now, and that is the North Atlantic temperature anomaly. And right now, since it's been brought to my attention, it's leveling out. It's at a negative 0.21 right now, and it's been that way for a few days. So it looks like it's leveling out, but if you look at the history, right after it drops, it levels back out a little bit and then drops again. So question is, will it make that turn again in a few days? We'll have to just wait and see. Snowfall. I got to show you guys 2 maps here. This map that I'm going to show you right now is the 24-hour snowfall. Or wait, is that this one? Let me double check. Let me make sure I got the right one. Okay, yep. So let's go back here. This will start off on April 2nd. Okay, now this is totals. In other words, this map is showing us how much snow is going to fall from April 2nd until, I believe this map goes until the 12th, and I'll pause this for you as well. This is really important, guys. Okay. So here we are. It goes all the way out to April 12th. Earlier today, I thought southern West Virginia, northern North Carolina, we're going to be dealing with lots of snow. This snow line has been drifting up north all day today. It started off very early in the deep south and has progressed upwards since. But what this map shows us here, folks, is the amount of snow that has fallen from the sky and accumulated since April 2nd. In other words, this map does not account for melted precipitation. So obviously, if we would let this run out till the end of the month and say this was March, you're going to see a lot of high values on snowfall total. So don't get this confused as if this is going to all come in the next 3 to 4 days. This is a 10-day outlook of snowfall. Still very impressive for the month of April, I'm going to admit that. But just wanted to make sure that we're all clear that that is just the total amount of snow that we're to expect in the next 10 days. Now, here is the snowfall as it happens per 24 hours, and we'll watch how it moves. Across the Great Lakes, into the Northeast, and again, I was looking at this earlier, and this line was definitely a lot farther south than what it is now. But this goes out to April 12th as well. Now, what we do see, unfortunately, is consistency here with wave after wave of snow. But what I like here at the very end of this forecast is that earlier today we had chances for heavier snow to build up in the northern plains on the 12th, and I'll try to pause it real quick when we get to the 12th. This has changed. This is an improvement, a big improvement. I paused it right there. If you guys notice, when we went into the 11th, some of that blue dissipated pretty quick. So this is a good sign. Earlier today, this swath that I'm going over right now with my cursor was actually in the purple. So as the hours go by, the chances of snowfall going closer into mid-month hopefully is starting to decay, as this storm chart is kind of, to me, it's directing us that hopefully the snow machine is getting ready to be turned off, as this is this coming week into later this week. As it goes out of the weekend, we still have a healthy chance of snow through early next week. And as we finally get to about Tuesday, Wednesday, the snow starts to get a little bit lighter. No more of those purples and bright pinks and whites anymore. So that's good. And the other good news about, even though we do have a lot of snow, and I'll go back to the total accumulation over the next 10 days, even though we have all this snow on the ground right now, that doesn't mean that this is going to be here very long, folks. We are in April, but I will show everybody, too, the temperatures as well. But the good thing about this, the ground hasn't stayed frozen. Now, there's been rumors as well about this weekend of a possible nor'easter, and I'll go ahead and start the forecast right here. And let's pause it right here. Now, I guess you could say that this low-pressure system would favor what a nor'easter would do. But two things about nor'easters. One, they usually rake up the East Coast and just hug the coast and goes out to the northern Atlantic. This storm right here does not originate anywhere near the south. So that's one thing it doesn't have going for itself. And if we take a look over here at this map, this is pretty much the Atlantic Ocean. And what we would need for a nor'easter is one of these high pressure systems that I've got my cursor over to be hanging out somewhere up here. And it has to be up here for several days. It can't just be for a couple of hours. That storm does not have that pressure system to grab onto to rake the coast like we've seen in March, where we had 4 nor'easters and 1 in January. And I'll go ahead, and when we get around back to the 8th of April, I'm going to pause this and we'll see if we can find maybe where there might be a possible high pressure system that's sitting close to Greenland that would help us favor this situation. Here, I'm going to stop it at the 5th. That high pressure system right here in the middle of the Atlantic, that's exactly where it should be right now. So let's see what happens on the 6th. Moving out into the 6th, still staying out in the middle of the Atlantic. And by the 8th, we see that system already forming its way off to sea. So right now, unless we have some kind of drastic change in our pattern with our high pressure system, it does not look favorable for any kind of nor'easter to develop from this coming storm that's going to be happening between Tuesday and Thursday of this week. Like I said, it does look impressive, but it just doesn't have the same type of ingredients to form an actual nor'easter along the northeast. But with that being said, right now the storm is just now getting kicked up. Tuesday, you see it's all over Ohio, Illinois, Indiana, Kentucky, Pennsylvania. You guys are going to be dealing with severe weather. Now, they're forecasting tomorrow, right here, a severe outbreak right where you see the cursor. We're going to see severe weather from Louisiana all the way to the Tennessee Valley, Middle Tennessee, Mississippi, Georgia, Alabama. You guys will be faced with some severe weather. Ohio as well, and that's going to come right around overnight hours. So I know in Southwest Ohio, they got somewhere around a couple inches of snow on Sunday. Tuesday, you guys are looking at 70 degrees for a high and severe thunderstorms overnight, possibly tornadoes as well. On the back end of this system is snow, and it cools us off here in the Northeast. And it looks like we will get some light lake effect snow, nothing major here in the Buffalo area. Look at the Northwest, more moisture coming in, of course, for them. This is a continuing cycle. This is interesting. By Friday of the weekend, most of New York will see some moderate snowfall. This looks like the 3 to 5 inch range, nothing major, but again, for this area, it's not unusual to see this kind of snow. But looking back here in the middle part of the country, this is where this storm system really gets its act together. And as we go through Saturday on the 7th, we could be dealing with a possible icing event in Illinois, parts of Missouri, and possibly even southwest Indiana as well. So we are going to be very, very alert about this upcoming storm this weekend as we are on Saturday, and there's 2 pockets of heavy precipitation. Looks like southern Ohio, Indiana, Pennsylvania, you guys are going to get some more snow. Very heavy snowstorm on the East Coast, but this moves off into the Atlantic. This was where people thought maybe that would have been a nor'easter. And yes, had this system continued to move the way it's moving right now, this is where the high pressure system would take that low and rake it up the coast of the East Coast. But since we do not have that high pressure system in place, we are looking at this storm to run off into the middle of the ocean with that high pressure system waiting for it. And then by Sunday, look at this, just a day later, we still got snow chances again in the Great Lakes, Ohio, the northern part now. The southern part got the snow on the 6th. Now they're getting rain on the 9th. Heavy precipitation as it develops through Monday of next week. Again, a chance for snow early next week for western New York, Pennsylvania, New England, that whole entire northeast corner. Again, looking at more snow chances. And again, in the south, we're probably going to be dealing with more severe weather and flooding. Northwest, a little bit of a break before they bring in our next system for us. It's typical. I think the folks at Region X Radio are just throwing all this moisture right across the country. So I'm going to go ahead and blame Region X Radio for all the... It's their fault for all this rain and snow. So hello to all the listeners out there at Region X Radio, by the way. But as we move through this snow system, I mean... Look, we're looking at April 13th, April 14th, still chances of snow in the Northeast, still chances of snow in the Northern Plains, and I don't know what's going on in the South, but it looks like every 2 to 3 days. Now that's interesting. The 17th, this storm system that goes up the coast takes a very unique position. We'll have to keep our eyes on that. That's an all-rain event right now, so we will keep our eyes on this. But that's almost 20 days away, folks. And, you know, it's one thing to go out 10 days, but to try to get someone ready for a storm that might not happen for 20 days is, we've seen how fast. Just today, I've seen the snow line move from Georgia all the way up to northern Virginia in just a matter of 7 hours today. So, again, it's good to be alert, and the temperature right now, unfortunately, I don't think they're going to let me go very far. Oh, it is. Great. So we see a lot of temperatures in the southwest, spring-like, heating up a little bit. North is still battling the cold. And, you know, as the daytime, you see that warm line go up. But as the nighttime temperatures, you see all this Arctic cold air coming in from Canada. And by the way, I wanted to mention before I forgot, Lincoln, Illinois broke a record low temperature yesterday. They got down to -1 degrees, and it was a very weird situation because other cities surrounding it were in the single digits, but this area in particular dropped all the way down to -1. And this record is worth mentioning. I believe they broke it by 21 degrees, and it's a very, very old record. In fact, I think it was the coldest on any April record they've ever had. So St. Cloud, Minnesota, you're getting ready to see -1 temperatures, and I believe that was also, there was another streak up there as well. But I mean, this is April, folks. -1 for the low in Illinois. Yeah, okay, I'm ready for spring. But looking at the futurecast, it looks like the cold air is going to stick with the Northeast and the northern plains. Spring is trying to happen, trying to push its way up north, but that cold air from Canada is still going to be persistent. I'm just surprised by the end of the month, let's hope. And I was saying this earlier last week. Last time we looked at the GFS at the end of the run, this is what it looked like. So now it's going to be cold. Again, these are just something to look at, to be aware of. This is not going to happen, to say on the nail, but it's always good to have that outlook of the possibility. And right now, this is the way the weather is shaping up to be. So we'll just keep our eyes on this, and hopefully we can get some springtime planting in here ASAP. All right, I think with that being said, I think I've covered everything tonight. Mari, did I skip anything tonight, or?
No, I think we covered most of it. Henrik actually said something interesting in the chat earlier. He said that Denmark broke a 100-year record for snow over Easter time.
Oh, wow.
Thought that was interesting. We got just a lot of great people in the chat, so just a shout out to y'all. Thanks for coming out and hanging out with us for this update. We really appreciate every single one of you.
Yeah, thanks again, guys, for tuning in. Please like and share, and we will talk soon.
Thank you for tuning in to the Grand Solar Minimum channel. Today I'd like to cover how a geomagnetic storm is ranked. A geomagnetic storm is a temporary disturbance of the Earth's magnetosphere associated with solar coronal mass ejections, coronal holes, or solar flares. A geomagnetic storm is caused by a solar wind shock wave, which typically strikes the Earth's magnetic field 24 to 36 hours after the event. Storms result in intense currents in the magnetosphere, changes in the radiation belts, and changes in the ionosphere, including heating the ionosphere and upper atmosphere region called the thermosphere. In space, a ring of westward current around the Earth produces magnetic disturbances on the ground. A measure of this current, the disturbance storm time, or DST index, has been used historically to characterize the size of a geomagnetic storm. In addition, there are currents produced in the magnetosphere that follow the magnetic field called field-aligned currents, and these connect to intense currents in the auroral ionosphere. These auroral currents, called the auroral electrojets, also produce large magnetic disturbances. Together, all these currents and the magnetic deviations they produce on the ground are used to generate a planetary geomagnetic disturbance index called KP. This index is the basis for one of the 3 NOAA space weather scales, the geomagnetic storm, or G scale, that is used to describe space weather that can disrupt systems on Earth. NOAA's 5-level system, the G scale, is used to indicate the severity of both observed and predicted geomagnetic activity. This scale is used to give quick indication of the severity of a geomagnetic storm. This scale ranges from G1 to G5, with G1 being the lowest level and G5 being the highest level. Conditions below storm level are labeled as G0, but this value is not commonly used. Every G level has a certain KP value associated with it. G1 is a minor storm. G2 is moderate. G3 is a strong storm. G4 is severe. And G5 is an extreme storm. With G5 storms, our power systems may experience widespread voltage control problems, and protective system problems can occur. Some grid systems may experience complete collapse or blackouts. Transformers may experience damage. Spacecraft operations may experience extensive surface charging, problems with orientation, and tracking satellites. High-frequency radio propagation may be impossible in many areas for 1 or 2 days. Satellite navigation may be degraded for days. Low-frequency radio navigation can be out for hours, and aurora has been seen as low as Florida and southern Texas. According to NOAA, this happens an average of 4 days per 11-year solar cycle. With a G4 storm, possible widespread voltage control problems and some protective systems may mistakenly trip out key assets from the grid. Spacecraft operations may experience surface charging and tracking problems. Corrections may be needed for orientation problems. High-frequency radio propagation may be sporadic. Satellite navigation degraded for hours. Low-frequency radio navigation disrupted. And aurora has been seen as low as Alabama and Northern California. According to NOAA, this happens an average of 60 days per 11-year solar cycle. A G3 is a strong storm. Voltage corrections may be required. False alarms triggered on some protection devices. Surface charging may occur on satellite components. Drag may increase on low Earth orbit satellites, and corrections may be needed for orientation problems. Intermittent satellite navigation and low-frequency radio navigation problems may occur. High-frequency radio may be intermittent, and aurora has been seen as low as Illinois and Oregon. According to NOAA, this happens an average of 130 days per 11-year solar cycle. With a G2 moderate storm, high-altitude power systems may experience voltage alarms, and long-duration storms may cause transformer damage. With spacecraft, corrective actions to orientation may be required by ground control. There may be possible changes in drag effect of orbit predictions. High-frequency radio propagation can fade at higher latitudes, and aurora has been seen as low as New York and Idaho. According to NOAA, this happens an average of 360 days per 11-year solar cycle. With a G1 storm, this is very minor. Weak power grid fluctuations may occur. Minor impact on satellite operations are possible. With G1 or higher storms, migratory animals are affected, and aurora is commonly visible at higher altitudes, including northern Michigan and Maine. According to NOAA, this happens an average of 900 days per 11-year solar cycle. We hope this has been helpful. Thanks for tuning in. Please like and share.
Great, so could you guys please introduce yourself?
Well, my name is Henrik Svensmark. I'm a researcher at the Danish National Space Institute. It is in Lyngby, but it's very close to Copenhagen.
And I'm Jacob Svensmark, and I'm currently doing my PhD. I'm the son of Henrik, and I've also been working with Henrik on some of the same things that he does.
Okay. And your views on climate change don't fit into the mainstream views of what people say are causing global warming. Could you run me through your theory in simple terms?
Yes, I mean, it all started more or less 2 decades ago, trying to understand why, when there was a change in solar activity, why there was a change in climate at the same time. And that was sort of a mystery, because you see these changes in climate over the last 10,000 years, which are very much varying together with solar activity. So what I've been trying to do is to understand what is the connection. And it turned out that it seems as if solar activity is capable of regulating the amount of cloudiness on Earth, and that regulates the temperature. This is really what we have been working on for nearly more than 20 years, actually.
So climate change isn't anything to do with the Industrial Revolution at all, as a lot of people would say so?
I mean, there's no doubt that CO2 is a greenhouse gas. I mean, when I started all of this, I had no interest or no idea about all this about CO2, but I very soon realized that it was a very, hot potato to say that the sun is very important and it has a large influence. So there's no doubt that CO2 is also affecting climate, but it looks as if that the climate sensitivity to CO2 is probably smaller because the sun is also part of what is going on. So that's probably why it's been seen so controversial what we've been doing. But it's actually just regular science.
And a lot of people are quite sensationalist about climate change nowadays, saying that we're out of time and so on, and that we've kind of ruined the Earth. So if it is the sun causing that instead, are we still headed for disaster?
I don't think we are headed for disaster because there's nothing in the record of data that indicates that the number of storms, droughts, whatever, hurricanes and so on, they are not increasing as you would expect from what all the things that you hear. So I don't think that we are heading for a disaster. And if the climate sensitivity to CO2 is smaller than what you get from all these climate models, then the change in temperature, in the next 50 years might be quite small.
So, Henrik and Jacob, you suggest that the solar activity has an effect on the cosmic rays and that the cosmic rays have an effect on cloud production. Now, how do we know that there's a correlation between solar activity and cloudiness? Do we have good data about that?
Solar activity and cloudiness, well, direct connection between those two observations. I think some of the most interesting thing that we have is Henrik started his work with exactly this, and this was published in 97, and it's been updated since, and it's a correlation between clouds and cosmic rays, right? It looks very convincing, and now there are some special events on the sun, which these coronal mass ejections, you call them. It's a big explosion on the sun which slings coronal ejecta out in space, and it hits Earth. The point of this is that it removes cosmic rays. Well, it suppresses cosmic rays for a period of time, like a week or something, from Earth. And the interesting thing is we can just go to satellite observations every time one of these events happen and see, okay, are there then in the same time period fewer clouds? And it looks as if that is exactly the case. So yes, we have some excellent data. And what else could that be over the course of a week that suddenly correlates with this solar activity or cosmic rays disappearing, right? Clouds doing that exactly, say, a week after, right?
We are moving into a solar minimum. Mm-hmm. So solar activity is going down in the next few years. What are you expecting, or what does your theory predict as a result of reduced solar activity?
It would be a cooling. I mean, the effect, when we have more cosmic rays, it means that you will get more clouds, especially low clouds, and this effect will be a cooling. And it's interesting because at the same time we have the increase in CO2, so that should give us a heating. And the maximum of solar activity we had around 1996, around that time, and since then it's actually started to go down, and we expect that the solar activity should cool the Earth. And it could actually be the reason why the temperatures are not increasing. They haven't been increasing for the last 20 years. And it will be really interesting to see what happens over the next 10 years.
Right. And if temperatures were to go up rather than stabilize or down, would you then hold up your hands and say, perhaps our theory isn't working as we predicted?
That might be the case. I think that at the moment, with the evidence that we have, which is far beyond just what is happening over the last 50 years, and if you talk about how climate has changed over the last 10,000 years, where it's solar activity, but if we start looking at changes in cosmic rays over the history of the Earth, I mean going back millions of years, we have huge variations, and all these variations which are completely independent of solar activity, but has to do with something completely different, they are also correlated beautifully with climate. So I think we have sort of opened up the window for a deeper understanding of why climate is changing. And it goes far beyond just this global warming. I mean, it could be that CO2 has a larger role now than the solar activity. It all depends on how the solar activity evolves, how much cosmic rays. And at the same time, because of the industrial activity, we are producing a lot of extra of these aerosols which are necessary for cloud formation. So this might actually affect, so you can imagine that if you didn't have this production of aerosols, you go back in time where it was much cleaner, then this effect that I'm talking about might be even stronger under these conditions. But I mean, this is things that need to be understood, and it needs more research into this field.
So you're saying that the industrial processes that we have now could actually be having the reverse effect? So they're producing aerosols in our atmosphere, which could be decreasing the temperature?
Yes, aerosols will probably decrease the temperature. So you put in an extra number of aerosols, and the solar activity is then doing some additionally on top of that. I mean, right now what I'm saying is sort of a speculation, so it's something that we have to figure out in more detail. But as I said, I mean, instead of just speculation, it would be interesting to see what happens over the next 10 years. I mean, then that will sort of decide for us.
Can I go back to when you said the temperature hasn't risen for the last 20 years? And why do you think that we hear in the news all the time, temperatures rising every year, record temperatures? Are they just wrong, or is there some kind of motive there?
It's true that we have been living in a period where we have the highest solar activity, and temperature has been increasing since the Little Ice Age in 1850. They have been going up over most of this period. So we are living in a period where we have high temperatures. So it's not very strange that we have some maxima. I remember people saying that 2014 was the hottest year on record, but if you look at the satellite data, it is not remarkable at all. I mean, 1998 is the hottest year. So temperatures are now higher than they were if we go 50 years back or back to the Little Ice Age. The question is how much of this heating is caused by humans and how much is natural. And I don't think that this question is answered fully at the moment.
And if it is mainly, if the temperature changes are mainly driven by natural phenomena like the sun, is it a lot of wasted effort and money going into, renewable energy and chasing after the Paris Agreement and so on? Well,
I mean, what we are doing is basic research, and of course it doesn't tell you what kind of politics that you should do. What I'm saying is that we are probably not heading towards disasters. So, I mean, it should open people's eyes towards that things might not be as bad as we think, and in respect to what policy and so on. Of course, what we are doing will not give you a direct answer.
Jacob, when Henrik published the initial papers the critics said it's really not possible for that mechanism to be that significant.
Mm-hmm.
What did your new paper that you published a couple of months ago introduce that wasn't available 2 or 3 years ago? What is the new finding of your paper?
That's a good question. So over 20 years, there's been a large body of correlations accumulating between direct or indirect measures of cosmic rays and direct or indirect measures of clouds and climate, right? And to sort of to point to somewhere, to underline how that would function, why there would be an apparent connection between those two things, you need an actual microphysical mechanism that says, in the case of a cosmic ray, this would make a cloud somehow, or affect a cloud at least. And so there has been also devoted to answer questions regarding what is the mechanism that can couple cosmic rays and clouds. There's been devoted a large experimental effort from Henrik and our group and so on. The latest thing that we've discovered, the latest paper here a couple of months ago, actually uncovers in detail what is it points to a mechanism. How can a cosmic ray that makes a little charge, an ion, or multiple ions, how can they somehow help towards growing the seeds of cloud droplets? So and of course there's a lot of technicalities involved in this, but it turns out that ions contribute with a little bit of mass, and because ions they have an electrical charge, they tend to jump onto small clusters of something that water wants to condense onto, and become a cloud droplet. So before you have a cloud droplet, you need an aerosol, a big aerosol, and cosmic rays and charges, ions, help this process to grow aerosols large enough that water wants to condense onto it and become a cloud. So what it is in essence a mechanism, an actual mechanism that substantiates the correlations that we see between cosmic rays and climate. Right?
Can you really recreate the conditions in the lab?
Yeah, that's a good question. To some extent we can. We devote a lot of energy into trying to do that, but then there are some issues with measuring and noise and stuff like that. So there are some conditions that are somewhat different inside of our reaction chamber in the basement of DTU space. Of course, we cannot recreate all processes, but as far as we see it now, it should only be more effective in the real atmosphere compared to the conditions that we have in our chamber. So it looks as if we've found something that's actually really interesting. Yeah.
But the proof of the pudding at the end is the predictive power of your concept.
Right.
Because, as I said, we are now going into an experimental phase where solar activity will reduce quite significantly. And as Henrik said, he's expecting some kind of cooling effect as a result, whether the temperatures will stagnate or whether they will actually go down. So you're putting your head in the ring in a way. You're actually making your theory makes a clear prediction that less solar activity should have a cooling effect.
Less solar activity will have cooling effect, and we see that in all the historical data. But also these events on the sun, you can say that they are also a natural experiment with the whole Earth. So you see the cosmic ray drops. You see we can actually also measure aerosols in the Earth's atmosphere. We can see they drop also, and the clouds are dropping.
Why would the aerosols drop?
The aerosols are dropping because we have fewer cosmic rays. That means that the cosmic rays are not producing as many cloud condensation nuclei. So there's a deficit of...
Right.
So, and this deficit, it takes about 5 to 7 days for the aerosols to grow. So we see also these delays in the data. So these are, as I say, what I would call natural experiments with the whole Earth. And the interesting part is also that the forcing that you get from this is on the order of 1 to 2 watts per square meter, which is quite large. And the change in cosmic rays is more or less what you get over a solar cycle from these explosive events. So it seems as if these events, which are very short term, are consistent with what we also see over a solar cycle, where we can measure the amount of energy that goes into the oceans, which is also on the order of between 1 and 2 watts per square meter, which is 5 to 10 times larger than what you get from the solar irradiance over the 11-year cycle. So there's we have a very, very good consistency now between theory and the observed effects. So when you ask the question, can we use the experiment to say something about the real atmosphere? And people have of course been saying that things are much more complicated in the real atmosphere. But then we have these events which is happening at the sun, and we see a very clear effect. So I feel very confident that we are on the right track.
And so you do expect temperatures to fall in the next couple of decades then, global temperatures?
Yeah, I don't know if I expect temperatures to fall, because what I expect is that there's a stagnation of the temperature, that it will not go up. I mean, the temperature is not rising as much. I don't know how much the solar activity will change. I mean, we could go into what we call a grand minimum. And that is the same as we had, called the Maunder minimum, which was from 1645 to 1715, where you saw no sunspots for a long period. If we hit such a minimum, then of course the cosmic rays might increase even more, and that might actually, we could risk a cooling. But in that case, we probably will be happy for the effect of CO2, that it warms a little bit, because cooling is far worse than heating.
What effects would that have then, cooling compared to global? Because we always hear that the world getting warmer is causing floods and... Yeah.
I mean, but if you look at the Little Ice Age, where it was during the Little Ice Age, where it might be 1 to 2 degrees colder than, globally, there you had big problems for the population. You had famine because the harvest didn't... you have frost in the months of May. So it gave big problems for people. Is
that something that could happen realistically in the near future?
I hope not. I hope not. I mean, I don't like all these disaster scenarios to sort of. But cooling would be a much worse situation than a slight warming.
Are there any other research groups internationally who are working on cosmic rays and climate change and are basically trying to replicate or to show similar effects or different effects? Are there other groups that are working on these issues?
I mean, there are other people in the world. So there are people like from our own group, like Martin Enghoff. There is Nir Shaviv of Israel, but I would consider them to be within our group.
Yes.
CERN does some experimental work on this, which is good. But I think, also, and it couples also to your previous questions about the predictive power of the theory. I mean, what is really done here is that we have a lot of very good correlations and a clear mechanism that couples cosmic rays and clouds and climate. But there is still a need for extensive modeling and more, I mean, a large body of research, and I think there's really, a lot of understanding and scientific opportunity and all these nice things, beginning to talk loudly, if not scream at us, that stuff needs to be worked out here, and I think, I mean, at least compared to that. There's not much people working on that.
Right, because you've put basically a challenge on the table for other researchers to show that you're wrong. So they have to now come up with research to show if there's a sound or if there are any flaws or any holes in your theory. And that was my question. Where are the people who are trying to replicate your experiments and to show, how solid your research findings are?
Yeah, that's a good, the hope is that more people would go into it and try to understand these things. So far, all we have heard is that people sort of repeat saying that what we're doing is not really important for climate. But you're right. The thing to do is to hope that someone will replicate it. Our first experiment that we did in 2007, where we saw that we produced very small aerosols from ionization, that was reproduced by the Cloud project in CERN in 2011. So perhaps they also will figure these things out. I should say that these experiments we've done are not easy. They were quite a challenge. It took 2 years to get the data. So
right. Well, it's a challenge, and good luck. And the next 10 years will show how good your theory is.
Exactly.
Thank you.
Sorry, could I ask one more question?
Of course.
Which was, we were talking about researchers and other researchers looking into it, and you said that's quite limited. Why do you think scientists across the world investigating global warming, I know this is speculative what you guys are doing, like you said, but why are most scientists so fixed on the idea of fossil fuels causing climate change?
It's again an excellent question, but the thing is that most of the funding, is going into this type of research. If you make a research proposal saying that you want to study, that the sun might have a larger role or something, I mean, it will be very difficult to get it funded. That's at least my experience in this.
Okay, thank you.
Henrik, Jacob, thank you very much, and good luck.
Thanks.
Thank you.